In 2017, an object unlike anything seen before passed through our solar system. Astronomers named it Oumuamua, and its strange shape and motion sparked years of debate. Now, a new tool has entered the conversation: quantum artificial intelligence. For the first time, its advanced models have pieced together hidden patterns in the data, offering answers scientists could not reach before. The results challenge everything we thought we knew about interstellar visitors. To get into the secrets quantum AI has revealed, we need to revisit the moment the mystery began. The first messenger. It was October 19, 2017, and the night sky over Hawaii was as beautiful as ever, filled with stars. From the Haleakala Observatory, a telescope named Pan-STARRS was doing what it did every night, which was scanning the night sky, looking for anything out of place. On this particular night, it found something that looked like a faint blip of light, moving across the cosmos at a speed that didn't make sense. The discovery was shocking, to say the least, and for the first time ever, there was proof of the possibility of a visitor from another planet. This mysterious traveler needed a name, something that everyone could remember it by. The astronomers who found this moving light decided to name it Oumuamua, a Hawaiian word that means scout or messenger from afar. It was a perfect fit for an object that had crossed unimaginable distances just to say a quick hello. At first, scientists thought it was a comet. But after a while, they were a bit disappointed when they realized it didn't have the fuzzy cloud or long tail that comets usually get when they get close to the sun. So they thought this moving light was an asteroid, but that theory was debunked later on after finding out asteroids are usually solid. What they saw in the sky that night looked like it was speeding up as it moved away from the sun, almost as if something was giving it an extra push. The scientists were completely baffled. The more they tried to figure out what it was, the less it seemed to fit into any category they had. There was a weird feeling that they were looking at something completely new. But it was that one strange, tiny push that would ultimately change everything we thought we knew. That tiny push is what scientists call non-gravitational acceleration. It sounds complicated, but it's really just a way of saying that something was nudging Oumuamua along, pushing it faster and faster away from the sun. The strange thing was that gravity was the only force that should have been affecting it. This was the main mystery and the one thing that made Oumuamua very unique. For a while, scientists tried to explain this acceleration by going back to the comet idea they once had. When a comet gets close to the sun, the ice on its surface heats up and turns into gas, which then shoots out into space. This gas acts similarly to an engine on a rocket, giving the comet a little extra speed, which is a common phenomenon understood by astronauts. That's why they probably thought this was the answer they were looking for. But that theory fell apart the more they studied the data from the moving light. The moving light didn't leave any trail of dust or cloud, it was completely dry and intact. It just didn't resemble anything that looked like a comet. Its acceleration was smooth and steady, not the sputtering, unpredictable kind planetary scientists would expect from a chunk of ice and rock. With the simplest explanation ruled out, scientists were left with a vacuum of understanding, and into that vacuum stepped the most audacious theory yet. The alien artifact hypothesis. That theory came from a well-respected Harvard professor named Avi Loeb. He looked at all the strange things about Oumuamua, from its bizarre acceleration to its lack of a tail down to its unusual shape. This brought about a ton of unanswered questions about whether or not the moving light was a natural object or if it was something artificial, maybe a spacecraft created by aliens. His idea, while controversial, was both simple and compelling, stating that Oumuamua was a light sail. What he meant was that this moving light was a giant, thin sheet formed to be pushed through space by the force of light from stars. Since the sun constantly sends out tiny particles of light, there's no doubt that this light could possibly hit any celestial objects. And when these objects are hit, they create a small amount of pressure. On Earth, this pressure is way too small to notice, but in the emptiness of space, over millions of miles and with a big, thin sail, that pressure can add up to a significant push. This concept perfectly explained the strange acceleration without any visible gas or dust. Loeb's theory gained more light when scientists got a better idea of Oumuamua's shape. Even though they couldn't see it clearly, they could see from how bright it was that it tumbled through space. From this, they figured out it was either very long and skinny or incredibly flat. If it had a flat shape, that would explain how easily it was able to catch the light from the sun, making it an ideal light sail. This all made sense, and it all fit together. It was an easy and only explanation to the mystery. As anyone would expect, a lot of scientists weren't on board with this idea. The claim of alien technology was a huge one, and most people wanted a more rational explanation. They argued there was something about Oumuamua, possibly a new type of natural object that they had just discovered. But as the debate raged on, the chance to study the object was quickly running thin. Oumuamua was getting farther away every day, and soon it would be impossible to see. And just like that, the mystery in the skies would be lost forever. But what if there was a way to revisit its journey, not only by relying on a telescope but also with a new, groundbreaking technology, and what could be uncovered? The dawn of quantum AI. The problem was that after its discovery in 2017, Oumuamua was gone. It was already traveling away from our solar system at an incredible speed. The data obtained was limited, as it was just a few weeks' worth of observations. Trying to figure out its full, complicated journey through space using regular computers was a nightmare. A normal computer, no matter how powerful, would take years and even decades to calculate something as complex as this mysterious moving light through interstellar space. The task was simply impossible. But this is where a new dawn of advanced technology comes into play, one that didn't even really exist back when Oumuamua was first spotted. Today, there's quantum computing, a whole new way of doing math and processing information. Unlike the computers back then that worked with simple ones and zeros, quantum computers can handle a huge number of possibilities at the same time. This makes them perfect for solving problems that are too complicated for regular computers to handle. So, scientists had an idea of taking all the limited data they had on Oumuamua and feeding it into this technology that had the artificial intelligence needed to decipher all they couldn't do. This quantum AI could then simulate every possible path and every tiny interaction Oumuamua had on its journey, all at once. It could, in a way, create a perfect digital twin of the object's trip through space, allowing them to draft out what they documented and really put into perspective what really happened. It would be a way to solve the mystery with a whole new kind of mind. The new model was about to reveal more than just a trajectory. It was about to pull back the curtain on a secret buried in the deepest reaches of interstellar space. With the quantum AI now fully integrated, the digital twin of Oumuamua's journey was ready and locked in. The AI didn't care about the old theories. It focused on the data and every little detail connected with the moving light and began to put the puzzle pieces together in ways no human or regular computer ever could. The first thing it noticed was the bizarre acceleration wasn't a constant push. Instead, it was a finely tuned series of micro-adjustments that birthed a whole new theory. The biggest shock came from its analysis of Oumuamua's inbound journey. It wasn't just a simple, straight shot through our solar system like other scientists had proposed. The quantum model revealed that on its way in, the object had actually slowed down. Not only that, but it had actively decelerated to avoid a closer pass with the Sun and then settled into a precise, temporary holding pattern far our solar system's most distant planets. In simple terms, it's parked itself. This wasn't the typical behavior of a random piece of rock, it was deliberate. During the course of the analysis, speculations began to fly about how Oumuamua only began its journey toward the Sun when a specific, predetermined event occurred, which was when Jupiter and a distant star aligned, but that theory was never fully confirmed.